Dracula's Chivito, the largest planet-forming disk ever found. There's a cosmic hamburger floating 1,000 light-years away, and it's about to change what we know about how planets are born. Meet Dracula's Chivito, officially IRAS 2307/6707, the largest planet-forming disk ever observed, and it's wildly, beautifully chaotic. The discovery. Using the Hubble Space Telescope, astronomers captured unprecedented detail of this massive protoplanetary disk. For the first time in visible light, Hubble revealed a disk that spans nearly 400 billion miles, 40 times the diameter of our solar system out to the Kuiper belt. To put that in perspective, our entire solar system could fit inside this disk 40 times over. The disk is so dense and thick that it completely obscures the young star, or possibly two stars, hidden inside. All we can see is this enormous flattened structure of dust and gas, glowing at the edges and dark in the middle. It looks like a hamburger, or, as the researchers playfully named it, a Chivito, Uruguay's national sandwich. Why Dracula's Chivito? The nickname honors the research team's heritage. One astronomer is from Transylvania, another is from Uruguay, where the Chivito is a beloved sandwich. And when you see the disk edge on, with its dark central lane flanked by glowing layers above and below, the name just fits. But this isn't just about a clever name. This disk is breaking records and breaking expectations. What stunned scientists wasn't just the size, it was the mess. Hubble images show bright wisps of material stretching far above and below the disk, extending farther than astronomers have ever seen in similar systems. The upper layers are wildly asymmetric, with filament-like features reaching out on one side but completely absent on the other. "We were stunned to see how asymmetric this disk is," said co-investigator Joshua Bennett Lovell of the Center for Astrophysics. "Hubble has given us a front-row seat to the chaotic processes that are shaping disks as they build new planets, processes that we don't yet fully understand." Protoplanetary disks are usually fairly symmetrical. Material swirls around the star in a relatively organized fashion. But Dracula's Chivito, it's turbulent, dynamic, chaotic. The lopsided structure suggests recent infall of dust and gas, or interactions with the surrounding environment that are actively reshaping the disk as we watch. The disk's mass is estimated to be between 10 and 30 times the mass of Jupiter. That's enough raw material to build several gas giants, and potentially many more smaller, rocky worlds. In theory, IRAS 2307/6707 could host a vast planetary system, said lead author Christina Monch of the Center for Astrophysics. While planet formation may differ in such massive environments, the underlying processes are likely similar. This massive structure might resemble what our own solar system looked like billions of years ago when it was forming, except ours was far smaller and probably far less chaotic. Why it matters. Dracula's Chivito offers a rare opportunity. Its edge-on orientation means we can see layers and structures in unprecedented detail. The dust and gas block the star's glare, allowing Hubble to capture features that would normally be washed out. The level of detail we're seeing is rare in protoplanetary disk imaging, Monch explained. These new Hubble images show that planet nurseries can be much more active and chaotic than we expected. Both Hubble and the James Webb Space Telescope have glimpsed similar structures in other disks, but none provide the clarity, the scale, and the detail that Dracula's Chivito offers. This makes the system a unique, new laboratory for studying planet formation and the environments where it happens, Monch added. The chaotic, asymmetric structure challenges our neat models of planetary birth. We used to think protoplanetary disks were relatively orderly, gas and dust slowly collapsing and coalescing into planets over millions of years. But Dracula's Chivito shows that planet formation can be violent, turbulent, and unpredictable. Material doesn't just fall inward smoothly, it can be flung upward, pulled sideways, and reshaped by gravitational interactions we're only beginning to understand. And the fact that the filaments, extend so far on one side but not the other? That's still a mystery. Scientists suspect it's related to how material is falling into the disk, or how the disk is interacting with its surroundings, but the exact mechanisms are unknown. The bigger picture. Discovering the largest planet-forming disk ever observed reminds us how much variety exists in the universe. Planetary systems don't all form the same way. Some are small and orderly. Others, like Draculas' Chivito, are massive and chaotic. And both kinds can produce worlds. Right now, we have more questions than answers, but these new images are a starting point for understanding how planets form in different environments, and how systems like ours came to be. So next time you look up at the night sky, remember, somewhere out there, 1,000 light years away, there's a giant cosmic sandwich building planets in the most spectacular, chaotic way possible. Like, share, and subscribe for more space discoveries. And as always, keep looking up.